2014. So we have a triangle within center I and circumcircle gamma. All right. So let's draw this in circle. I is the center of D, and M, N, and P. So we draw the three midpoints. Let me do it this way so I don't. And P is the midpoint of AB. And then E and F are the points of tangency with CA and AB. So that's E. Let's try to make F a little bit farther away from P so it doesn't look like they're the same point. Let's see. All right. Okay. I think that's okay. And then, thanks for joining, Khan. So we want to show, let UV be the intersections of EF with MN and MP. So this looks kind of familiar. So we have EF. This looks like the Iran lemma or something, right? So I think BI and this point are collinear by the Iran lemma. And I think, yeah. So we want to call them U and V. So BI and U should be collinear, I think. And CI and V, I believe, are collinear. Oh, so the first part says prove that I lies on CD. So yeah, that's by the Iran lemma, right? I forget the exact proof, but I know I've seen it. Yeah, my brain just doesn't work the way it used to, but we want to show that XI, so X is the midpoint of arc VAC. Okay, so this is point X.
And the Iran lemma proof is just an angle chase, and I know how to do part 2.
Okay, so this is like a really easy one.
Yeah, because I don't know if you remember your first video, like when you have the altitude from M to EF, and that point lies on line XI. So I have read on ALPS one proof of that.
Okay.
That problem, and it is kind of similar to what we have to prove here, but like this is like a part of that proof, so I know it immediately.
Okay, so if you draw the perpendicular from M to EF, I think this is the first video on my channel, right? For the first problem, then X, D, and I are collinear.
Yeah, and like after we prove the Iran lemma, we can like use that video 1, or we can just prove it again. It doesn't really matter that much, but the M is the center of BVUC.
DVUC or DVU?
BVUC. BVUC.
Okay. So that because they're all right angles, right? BVC is a right angle.
Yes.
Yeah.
And when we take that,
by the way, like IX is the median line of triangle BIC, and triangle BIC is similar to triangle VIU. So ID must be the median line.
And how do you know IX is the median?
Oh, well, you can call the intersection of AI and circumcircle ABC.
Okay. So basically it's this point, right?
Yeah, and can you draw the circle with that point and radius that point in I?
Yeah. So G is the circumcenter BIC, right?
Yeah, so you can easily see that X is the intersection of the two tangents point from B and C. So it must be the median one.
Okay. So interesting. So therefore IX is the symmedian. I kind of like that. I feel like that's a really simple proof. Okay.
I think
so,
that is a lot easier than what I said. So better write that.
Okay. I'll write that up quick. Okay, let me just draw MV and MU. Okay, so that's part. So for part A, it's true by the Iran lemma. It's also just an angle chase. So I think the way I remember to prove part A and we did it in a previous video. But so it's supposed to be just an angle chase, right? I forget exactly how. Is it like we draw the circle centered at M and passing through B and C, and then we let the bisector hit it at U prime, and then we try to show MN and U prime are collinear? Oh, yeah, no, it really is just an angle chase because, yeah. So yeah, I'm gonna, so I'll say, so draw the circle with center M through B and C. And then let BI intersect the circle at U prime. Basically, it says that BI and U are collinear. So that's basically what the Iran lemma says. It says BI and U are collinear. So yeah, and also that BUC is 90. So so then let or actually, do we let EF intersect the circle at U prime? So okay, so what if I let EF intersect the circle at U prime and V prime? Then U lies on the polar of A, so A lies on the polar of U. So AM let's see. So U
Better proof firstly that BUC is 90 degrees, but a proof like this would go. So we do a phantom point U prime, where U prime is the intersection of BI and EF.
Okay, BI and EF. Okay, so
then I will just explain it firstly. And then we will prove by an angle chase that IEU prime C is cyclic.
Okay.
And afterwards, we will prove that U prime lies on line MN.
Okay. So let's see. Yeah, I've seen so many of these proofs, but yeah, my brain just is not as good as it used to be. So let BI intersect the F at U prime. And then we're going to show it lies on MN. All right. Sorry, my keyboard's having trouble. And then we can show that U prime EIC is cyclic.
Yes, and we will prove that by proving that ICE is equal to IU prime E.
Okay, so ICE is half of angle C, and IU prime E. So I guess AEF, we know that. Okay, so yeah, I think I see how we can calculate IU prime E, because if we draw this point right here, I don't know.
I think that point isn't necessary.
Oh, because IU prime E is BU prime V, which is BC. Or okay, you think this point right here isn't necessary?
Angle IU prime E, that is equal to angle AFE minus ABI.
Okay.
And both of those we can calculate.
AFE minus ABI. Yeah, you're right. Yeah. So, all right. So angle IU prime E is equal to angle AFE minus ABU prime. And then AFE is 90 minus A over 2, and ABU prime is B over 2. So that's equal to angle C over 2, which is equal to angle ECI. So IEU prime C is cyclic. Then once we know that, then it follows that then we can try to show U prime M and N are collinear, right? So
yeah. We will use that M is the center of circle BU prime C.
Okay.
Because of the 90-degree angle.
That's
and
right.
it is just important to show that mu prime is parallel to AB, and that would prove that those three are collinear.
Okay. So since angle BU prime C is equal to angle basically IE prime C, which is IEC, which is 90. So and so basically BU prime V prime, I could just say M is the circumcenter of BU prime C.
Yeah.
So all right. And then from there, how do we, so we want to show MU is parallel to AB.
I'll just tell the angle chase CMU prime. That is equal to MBU prime plus MU prime B.
Okay.
And that is equal to 2 times angle MBI. And
okay, that makes sense. So, so that means that angle CMU prime is equal to twice angle CBU prime, which is equal to angle CBA. So that means that MU prime is parallel to AB, which means that M, N, and U prime are linear. I'll just say that means U prime equals U. All right. I don't even know if I need to do these dollar signs because it's, let's see. But yeah, I think I just need to do this. There we go. So that's part A. And then for part B, I'll just leave it like that. Let G be the midpoint of arc BC. Oh yeah, Vietnam, they're all 2 parts. I did a video on it once. And then, so G is the circumcenter of BIC, and XB and XC are tangents. So yeah, I'd never seen this idea before, but it's a really good idea. So basically that means that IX is a median of the triangle BIC.
Yeah, and IX also passed through the mislinear tangency point too, I think.
Yeah. So so yeah, because the midpoint of this arc through and the line passing through X and I always passes through the mixed linear tangency points. So that's a good observation. So So basically IM and IX are isogonal. So since BIC, so IM and IX are isogonal, and then since BIC is similar to CIV, and they're inversely similar, but I'll just say BIC is similar to IUV. Oops, just a second. That means that IX bisects UV. And also passes through the mixed linear tangency point. I'm not going to type that out, but that's that's a good observation for like later problems. All right, I'm going to move on to the next one. So O and H are the circumcenter and orthocenter. Let's see, this is 2017. Oops, sorry, didn't mean to do that. So BM is equal to CM. So I'm just going to draw that midpoint. And then this is O. And then D is the foot of the angle bisector. And H is the orthocenter. I spelled, I mixed the I and the A. That's H, and we have M and D, and MO intersects the circumcircle of BHC at N. So this looks like an easier problem probably. Prove that angle ADO equals angle HAN. Wait, that doesn't sound right. Let me check this. Maybe I did something wrong. ADO.
We did this problem already.
Oh, we did it in the past?
Yeah, when we did the TST or TSTST. Like
oh, really? This
a couple
exact
of sessions ago. Yes.
But it almost looks like ADO. Are those angles really
I think
equal?
so. Maybe not. I don't know. But
Yeah, but the problem doesn't look right.
Yeah. Oh, it is true. It just doesn't look like it. Huh. Interesting. So yeah, I guess we did it before.
I don't know. Maybe we didn't do it, but I have seen that problem already.
It looks a little familiar. Okay.
Yeah.
It does. I do think we did it before. Let me. Do you remember the solution to it?
I think so.
All right.
Yeah, I know.
If you want, you could just say it right now.
Can I show my solution?
Yeah.
So A prime is a reflection of A over B.
Over BC.
Yes, it's obvious that A prime is
On the circle.
Circle BHC.
Okay. All right. That makes sense. Yeah, it's true by symmetry. Yeah.
Yes. And by using the inversion square BC.
Oh, using root BC inversion?
Yes.
Okay.
And we will have angle ADO is equal to angle A prime F.
Okay. So let's see. So does D go to A prime and O go to F under the inversion? Or D go to F and O goes to A prime?
Yes, D is to F and O is to A prime.
So yeah, D goes to F, right? Because
Yes.
AD times AF is AB times AC. And O goes to A prime because
Yes.
triangle AOC and ABA prime are similar. Okay.
Yes. And we have easily have that triangle
Yeah, I see
A
it.
and F I prime is isosceles trapezoid, right?
Yeah, it's you can see by symmetry it's true. Yeah. So
Yes.
interesting. Yeah, that just makes it really simple. I'm surprised they did a problem like that simple for USAJMO, but so I'll just type it up quickly. Consider a root BC inversion at A, and then so let A prime be the reflection, but you still have to think of the point A prime, which isn't, I guess, that hard, but it's something. Let A prime be the reflection of A over BC. So then A prime lies on BHC by symmetry. And that's because the reflection of H over BC lies on the circumcircle. All right, and so ABA prime is similar to AOC. Call this phi. So phi takes O to A prime and D to F. So angle ADO is equal to angle AA prime F. But then by symmetry, ANFA prime is an isosceles trapezoid. Sorry, a lot in the chat, I see. And that means that angle ADO is equal to angle AA prime F is equal to angle HAN. All right. So yeah, it's not that easy if we didn't see A prime. Yeah. So Okay, so Stefan says he did it a way where he showed ADON is cyclic and he used power of a point. Interesting. And then once he knows that's cyclic, then ADO, it's 180 minus ANO, which is HAN. Yeah, interesting. So you use power of a point. So maybe you said like MO times MN is MD times this point, maybe? I'm not sure.
I think by an angle trace I proved that FCO is FNC, and then power of point FO times FN is equal to FC squared, and that is equal to FD times FA.
Interesting. So yeah, that's a cool way to do it. And then you don't even need to use root BC inversion. I feel like there's a lot of problems where you use like power of a point with this point F. Let me just define F before I move on to the next problem. That's a nice solution too. All right, so I'm going to move on to the next one. Let's close this for now. And yeah, it's only 11:04, so yeah, we might end up going back to that other problem. This looks kind of interesting. So we have a quadrilateral in a semicircle with diameter xy. So I'm going to draw a diameter. So this should be x, and then call this O, and y, and A and B, and so AX, A, B, Y. AX and BY, AY and BX meet at P. And then Z is the perpendicular. So it looks like we have orthocenters here, right? If I, like P would be the orthocenter of the triangle if I extended AX and BY. And then I drop a perpendicular here. So, so here we have Z, and C lies on the circle such that XC is perpendicular to AZ. So I'm going to draw the perpendicular again. So we have X, so that would be point C. And then Q is the intersection of AY and XC. That's Q. And then we want to show this equation. So another algebra problem. I'm gonna extend AX and CY to meet, just because I think could be useful. And since P is the orthocenter, oh, I thought P. Oh, I'm sorry. I'm going to extend AX and BY, and then P is the orthocenter of that triangle. There we go. All right, so could make it a little bigger.
ABOZ is cyclic because of the 9-point circle.
ABOZ, yeah. So ABOZ is cyclic. We draw this point. Hide a few things. X, Y. Let's see. Okay, so I want to draw XQC. This. XC is perpendicular. Okay, so All right. So we have all these right angles, and XC is perpendicular to AZ. So basically BX and Q, XQ and XP are isogonal, right? Okay, so we have two isogonal lines. What do we want to show? BX over XP plus CY over XQ. Yeah, so it's kind of random what they're asking to prove. So almost reminds me a little of Van Albel's theorem. So BX over XP. It's just so random. Yeah. How do you get XQ here? Yeah, it seems like a really random calculation. So maybe we want to rewrite it. Let's rewrite this. So we have by times ax over xp plus cy times ax over xq is equal to ay. I kind of feel like that's a little easier to think about.
Can you call the intersection of AZ and XC?
Oh, this point right here.
AZ and
Yeah.
BX, now XC.
Okay, right there.
Yeah. Then I think the use is that, now I just think that XPEB is harmonic, and I don't know if we can use it.
Use that somehow. It's possible.
I was trying to find a way to use the point Q, but
yeah, so those are harmonic. So AX over XP is the same as BY over YP. So yeah, let's rewrite this. So this is true. This is the same as saying BY times BY times BY over YP. Plus CY times CY over YQ equal to AY. You got a BY squared and a CY squared. So I'll just change this to squared instead. Looks a little easier. Maybe we could even use Ptolemy here because we have by times AC plus AY times BC is equal to AB times YC. Then we would get the plus. But we need to get YP and YQ. So is Q the orthocenter of like a different triangle? Like if I extend, maybe I should like extend YC to meet AX. And then Q is going to be the orthocenter of that triangle. So they're like P and Q are both orthocenters of the two triangles, and it's kind of like XP and XQ are isogonal.
They are in fact isogonal.
Yeah, they are isogonal. Yeah. So yeah, maybe we can think of a way to calculate AY. So could it be, because AY is AP plus PY, and maybe each of them are equal to a different one of these? Is it true that AP times PY is BY squared? I would be surprised, but. So AP times PY is, or AY times PY. Yeah, maybe this is like equal to AQ BY squared. Could it be true that YP times AQ is BY squared?
Sorry, Michael, can I show my solution?
Yeah.
It's geometric.
Trigonometric.
Yes.
Okay.
So you can write down that put AY into.
Let me move this to the side. So yeah. So then when I type it up, you can see the diagram. So AY.
Oh, sorry. So just second line. I mean, I want the second line. You can put AY under BY and CY. Sorry. You can divide both by XY. Sorry. xy. So we will immediately have some geometry size.
Okay.
So dy over xy
dy.
Yes, by over xy is cos angle bys. Sorry, sine angle bys.
byx.
Yes, angle bys. Time sine angle is dy.
What
S-
dy? xby?
Yes, sdy.
Like s xby, or I'm sorry, what letter is this?
Sorry,
A?
sdy. Can I write out? On
Yeah,
the,
yeah, you can put in the chat, like xdy, like you can put in the chat if you want to. Yeah, I apologize. It's not easy to understand over Zoom. Okay. All right, let's check the chat. Okay. So I'm going to type it out.
the first line you divide both in xy and you will have this expression.
Okay, so all right, and then okay, so sine of a xy. So yeah, on the right side, that would be xy over ay. Okay, so basically we have xy over ay on the right side, and then on the left side, cosine dyx sine x dy. So, okay, so you're saying, yeah, because AXY is 180 minus the other two angles. So, okay, so, all right, so on this side, so cosine dyx, that's by over xy. Or, yeah, I'm guessing that's the best way to do it. And then sine x dy is ay over dy.
No, you can write out AS over SP. AS over SP.
Okay, so AX over XP. Like that?
Yes, yes.
Okay. And then cosine x dy. So before we said So for this, should we put like by over yp, or so let's see, x dy, it's that angle, it's the same as that angle, so bp over py is that good?
It's better to write down cy over x y sy, cy over sy.
Okay, cy over xy. And then sine dyx is just trying to think of the best way to do it. So that would be like bx over xy, right? So like this. Okay, so let me.
You have a mistake. Sine asy is ay over sy.
Okay, ay over xy.
And you have better write down bs as over sq instead of bs over sy.
As over sq, ax over xq.
Sorry, bs. You can write out as over sq instead of bs y.
Okay, ax over xq here, like that.
And just finish your problem.
Interesting. Okay, so let me turn these into fractions. Interesting. So it's really just using the angle sum formula for sines. That's really weird. I like your solution. Not the most elegant problem, but still interesting. Oh, I heard this too many times. It's just like this. All right. Okay. Okay, so cy over xq. Oh, so these should like, yeah, that solves the problem. So I'm just gonna write out a couple more steps. So where did we use that? Somewhere we use that P and Q are isogonal, right? So like we have a bunch of similar triangles that we used when we did this. So yeah, I'm going to delete this. So we have angle AXY is 180. Angle DYX minus angle XDY. And that implies sine of angle AXY is equal to sine of angle xdy plus angle dxy. Okay. And then we get this. So yeah, so let's go through each of these. So dyx, we're saying the cost of that is by over xy. Okay, that's and then x dy. We're saying it's ax over xp. Okay, and then x dy again, we want the cosine, and we're saying that's cx over xy, because there we're saying because x dy is equal to is x dy equal to cxy? I'm trying to figure out. So cos of x dy, we're saying it's cy over xy. So so this angle, okay, so we have angle cyx equals angle x dy. Because cyx is 90 minus this, which is 90 minus this. So yeah, I'll say cyx is 90 minus cxy, which is 90 minus dxb, which is that angle. And so that's how we can get all this. And then for dyx, it's like the same thing with this other fraction. I'm not going to write it out. But that's really interesting how they kind of just use the angle sum formula for this problem. It's kind of weird for Olympiad geometry. But yeah, thanks for your solution. So here's the last problem. So this is from 2012. So we have a triangle ABC. And we just have any point P and any line passing through it. So this is point P. And so I looked at this, it feels like maybe you used Desargues a bunch of times. So actually, really, we want to draw the lines A, B, B, C, and C, A, because we're going to be reflecting. We're going to draw PA, PB, and PC, and we're going to reflect it over that line and see where they meet the opposite sides. And then we want to show that those 3 points are collinear. So let's see. I want to make it easy to reflect those three. How should I do that? So if I just pick, let's say, this line. Kind of think that's not so bad. Okay, so if I reflect PA over it, and I want to see where it meets BC. So that would meet BC at this point. So that would be A prime. And then I reflect PB over it. And then I want to see where that meets AC. So this would be B prime. And then I'll do one more reflection. So PC, I want to see where it meets. Oh, I think I did. Oh, no, that's right. So then this is C prime. I kind of like this diagram. So yeah, it feels a lot like Desargues. Let me check the chat. Oh, right. So no, DDIT, I'm fine with the solution using, well, but is it just using like the isogonal line lemma? So hold on, let me first hide, whoops, I didn't mean to do that. Let me first hide a couple things. And then, yeah, I'm still interested because like I have the isogonal line lemma as like a video on my channel. Let's see, I'm just gonna hide a whole bunch of stuff and just draw the lines that I need. All right, so that's PA, PB, PC, and then like that. All right, so let's check the chat. Oh, okay, so it's something more general than the isogonal lemma. Okay. All right, then maybe let's see if we could find another way. Yeah, the isogonal lemma is a specific case of but I guess for this problem specifically, does it just use the isogonal? But like for this specific problem, that you only need the isogonal lemma, or you need the whole DDIT? So dual Desargues involution theorem. That's what it stands for. Yeah. So I could I'll show a link to the article. Yeah, so dual Desargues involution theorem. Let's see. So here's a good page with it. Just put it in the chat. Yeah, it's something with conics, but it's having some trouble opening it. I can see I visited it 3 times. It's having some trouble downloading. But here's a cached version of it. But yeah, you can't see the pictures here. So yeah, just go Google it. But yeah, I looked at it for a while. It's pretty hard. But I guess, Nguyen, for this specific problem, do you need that whole theorem, or you just need the isogonal case to solve this one? Like, to solve this problem, do you need the whole DDIT, or do you just need the isogonal special case of it? Anyways, we can keep looking at it. Okay, interesting. All right, let's see if we can figure this out. So maybe there's a solution just using the normal Desargues theorem. So we want to show, we have a lot of isogonal lines, right? So PD is like the main line, then PA and PA prime are isogonal, PC and PC prime are isogonal, and so are PB and PB prime. So if we look at PB prime, PA, PA prime, and PB, if those are isogonal, then let me see how this works. Then if we let C be this point, and then if we let B prime and A prime intersect, then basically I think, I thought that PE and PC would be isogonal, but it doesn't look true. So let me think about this a little more. So yeah, I thought E would lie on PC prime, but it didn't. Oh, you know what?
I think that this problem can be solved by using isogonal lemma, not
Okay.
using T. Yeah, we have PA and PA prime isogonal, B prime are isogonal. So the intersection of B prime A and A prime B.
So, B prime A and A prime D. So yeah, so I let E be the intersection of those two, right?
B prime A and A prime B.
Okay. Yeah. So C is the intersection of those two, right?
Yes, and B and A prime B prime. That we denote C prime prime.
Okay, so hold on a second. So all right, I'm gonna go delete this. And so, oh, do they intersect? So yeah. At C prime. So I knew they'd intersect on the line PC prime, but I didn't know they'd have to intersect exactly at C prime. So like, for example, how do we know that they don't intersect at this point, right? You kind of see what I mean? Because like whatever point they intersect at, I know it has to be isogonal with C, right? But how do we know it's C prime?
By using the isogonal, so let me denote C prime prime is the intersection of A prime, B prime, and AB.
Okay, so we call that C double prime.
Yeah. So by using isogonal lemma, we have PC double prime is isogonal with PC. So, and we all know that PC prime are isogonal with PC, and C prime is also lies on AB. So C prime is
equal to C prime.
Yes.
Okay, so let's see. So I'm gonna hide this for a sec. So we let C double prime be oh, because we defined it to lie on A prime B prime. So it has to be, wait, let me think about this for a sec. So yeah, so yeah, that solves it. It's really just that okay. So yeah, so I'm going to type it up quickly and then we can go back to that last problem. Yeah, I know, sorry, the problems, it's harder for me to find harder competitions. So if you guys know any ideas or have any competitions that you want me to take a look at, feel free to post them on Discord. But I think what I might start doing is, instead of doing like competitions, just because I'm running out of them, I might look through like posts of people on AOPS and start just using those instead. China TST. Did I do China TST already? I think I might have, but I'm gonna go check. So, all right, so, oh, it's too hard. So let AB intersect A prime, B prime at C double prime. And then basically, so we have PA and PB. Yeah. PA prime are isogonal with respect to L. And so are PB and PB prime. So by the isogonal line lemma, PC and PC double prime are isogonal. PC and PC double prime are isogonal with respect to L. And then, so we have C double prime lies on AB and is isogonal to PC. And the same is true for point C prime. True for C prime. So then we have C prime equals C. C prime equals C double prime. And that means that A prime, B prime, and C prime are collinear. All right, let me check the chat. So yeah, this problem was kind of too easy. Hong Kong TST. Yeah, if you find random problems, yeah, feel free to post it on Discord and I could do them on the sessions. Hong Kong TST. Okay, I'm gonna write these down. So Hong Kong TST and China TST. Oh, this is a different isogonal line lemma than what you know?
Yeah, the one that I know is like, it has a triangle and an arbitrary point P in it. And then you just reflect AP over the angle bisector of BAC. And you reflect BP over the angle bisector of ABC. And reflect PC over the angle bisector of BCA. Then they all concur at a point.
Okay, yeah, no, that is different from what I was thinking. So here's the isogonal line lemma. It's a video on my channel. It's just called isogonal line lemma. But like, let's say you could really have, so let's say we draw the line isogonal to H. Oh, hold on just a second, Stefan. I will do that. Yeah, okay, we probably don't have time to do it now. I'll take a look at it. So let's say we have something like this. You can really pick, yeah, on a different session. Yeah, we can do it. So oh, a different one from BGO. Okay. So like these lines are isogonal, right? FH and FI. Yeah, I did Iranian geometry Olympiad before. So here's the isogonal line lemma I was thinking about. So FH and FI are isogonal, right? And then it turns out that if you intersect these two, and you intersect these two, you get two new isogonal points. Oops. So if I intersect EI and GH, and I intersect EH and GI, so I have these 2 points right here, it turns out that these two are also isogonal, which is pretty surprising, right? So it almost looks like they're collinear there, but like, let's say I did it like that, then angle JFG is KFE. Isn't that interesting? So yeah, this is the theorem I was talking about.
Yeah, so how do you prove it?
Yeah, I did a video where I proved this. So yeah, it's just called isogonal line lemma. So it might be like video, I don't know, 60 something. So if you look for it, you'll see it there. All right, so I'm gonna go back to that one problem that we didn't finish yet. All right. Oh, whoops. Didn't want to delete the problem statement. All right. Is it this one? Okay, let's see if we can finish it. So we got it all the way down to this. AF over AE plus BF over BB equals 1. That almost doesn't look true because it is AE looks like, is AE more than twice AF? Let's see. Oh no, it's not twice AF. It's less than that. Okay. So
that is true. I checked it in the algebra part of GeoGebra.
Okay. So that's true.
So we haven't made a mistake.
All right. So AF over AE plus BF over BB. So that, So if these ratios were equal, then they'd be similar, but they're not equal, they just add up to 1. So I wonder, I don't know if there's a way to rewrite that. So how would we calculate E?
Oh, I have finished. Yes, it's quite easy.
Okay.
So we have triangle APF is equal to triangle EPA, right? Yes, angle chasing.
APF is similar to EBA.
Yes, sorry, similar. Yeah. So, AF over AE is equal to PF over PA. And
Okay. AF over AE is BF over BA.
And similarity, we have BF over BD is equal to PF over PB.
Okay. Okay, so you're using similar triangles. So AFE is similar to
No, AFP.
AFP is similar to
EAP.
They don't look similar though. AFP and EAB or EAP.
EAP.
Oh, EAP. Okay.
Yes.
So AF over AP. Okay. So say the first fraction again. AF over AP.
AE, AF over AE.
AF over AE, and
Yes.
that's equal to AP over PE.
Equal to FP over AP. Yes. And BF over BD is equal to FP over BP.
Okay.
And
so then we can add the two, and they both have okay, so that's the same as 1 over AP plus 1 over BP is FP?
yes,
Interesting.
BC. Can I say?
Yeah.
FP over BP plus FP over AP is equal to FP times 1 over AP plus 1 over BP. Yes. And
so that's
CP over AP times BP, and it's equal to 1.
Okay. Over. So I think it's like this, because you use Ptolemy's, right? Because AP plus BP is PC, right? So
Yes.
BP. All right.
Sorry, you had some mistake.
Okay. Oh, this should be these should be P's, yeah. PB, and this is 1. Let's think about this.
By similar triangle too.
Okay, this is interesting. Okay, so I am going to just say, I'm just going to write in the very beginning by Ptolemy. Oops. Then I'm going to make some of these nicer. Just want to, she is making it very hard for me to move this. Move it. There we go. Finally. All right, so I'm going to say by Ptolemy. PA times BC plus PB times AC is equal to PC times AB, implies PA plus PB equals PC. Okay, so we use that there. And then so yeah, I'll just add in another step where I say CFD, CED or DEF is equal to CED minus ABC, B minus BFD. Okay. Let me just put this in LaTeX. So it looks nicer. So yeah, we use some similar triangles there. I wonder if there's an easier solution to this. I feel like there has to be. So yeah, after the session, it'll be interesting to see if we can find it. This is still a pretty cool one. We figured out all this extra stuff that we didn't need, but still good stuff to know. All right, looks good. All right, so I think I'm going to end it here just because we finished. So yeah, next time I'm going to look for harder problems. If you have any like single problems you find, you can put it on the chat and Discord, and I'll do it on the next session. But I think I might start, instead of doing contests, like I'll check out China TST and Hong Kong TST. If I've already done those, then I think I might look through like posts. So like there's this one poster that posts a lot on art of problem solving on the forum. His name is Jean-Louis Aimé. I think he's like a professor in France, and he has a website that has like a lot of problems. And I emailed him and he said I could do them on my channel. So if I ever run out of problems, I might like start to do that. But thanks everyone for coming on. So yeah, I'm pretty happy we got through all the problems, and I will see you next time. Have a good one.